Good morning, class. We are looking at chapter 5, trigonometric functions, and here's the first section, angles and their measurements. Here's the second part. So, radian definition, the measure of a central angle subtending an arc equal in length to the radius. And it becomes almost 57.3 degrees. It's 180 divided by pi. In other words, if you look at these graphs, okay, the idea is, let me just move this. The idea is that doesn't matter the circle has a large or small radius. The central angle subtends an arc if the length of this arc is equal to the radius, as it is the case here, over here, it's just r in general, 1 radian. If this is 3, so is this, just as an example. And so finding the length of an arc of a circle is fairly simple, okay? Arc length is the length of the arc of a portion of a circle, part of the total circumference of a circle, given a central angle theta, S equals R theta. Here's what's happening. If you compare theta to theta 1, then you can compare S to S sub 1. And reminding you, the circumference has the equation 2 pi r, C equals 2 pi r. And 2 pi is a complete revolution, everybody. 2 pi is a complete revolution. So in essence, C is the same as arc length, which is the circumference. So instead of 2 pi, if we have theta, then theta times r, simply put, S equals r theta. Here's a simple example. Find the length of the arc of a circle of radius 4 meters, subtended by a central angle of 0.5 radians. S equals r theta. R is 4, theta is 0.5, so we get 2, and the units are the units of the radius. The units of the radius. I can't emphasize this enough. 2 meters. Convert degrees to radians and radians to degrees. Remember, 1 revolution is 2 pi radians, or 360 degrees. So pi would be 180 degrees. So 1 degree is pi over 180 times pi over 180 of a radians, and 1 radian is 180 over pi of degrees. And to make it nice and easy, look at this formula. D over 180 is R over pi, because 180 degrees is the same as pi, then D at top of that and R at top of the, pi. If you have any of them missing, replace it. So you have the radian, put it here, find the degrees. You have the degrees, put it here, find the radians, or just multiply it in this fashion by pi 1 over AD, or 180 over pi. And there are some common arcs or angles we are supposed to know. For example, 0, of course, is 0. 30 degrees is pi over 6, 45 degrees pi over 4, 60 is pi over 3, 90 is pi over 2, 122 pi over 3, and so on. I hope we all remember this is from a basic trigonometry we've had. Very straightforward. 135 is 3 pi over 4, 150 is 5 pi over 6, 180 is pi, and so on and so forth. So those are some common arcs or angles. All right. We want to convert from degrees to radians, as I mentioned over here. If I want to go with this formula, basically I put 30 here, and I calculate the R. 120 minus 60, 104, I calculated, or simply times, if I wanted, because 1 degree is pi over 180 radians, just multiplied by pi over 180. Either way is fine. So you do that, 30 and 180 are divisible, so you get pi over 6, something we already know. These are some of the common arcs. 120 degrees, we do the same thing again. You can do it the way I told you. This is a very nice and easy way to do it. Or if you do it this way, obviously both of them are divisible by 60. We get 2 pi over 3, 2 pi thirds radians. And negative 60 is also a common arc. And 60 and 180, they cancel each other. We get minus power 3. So those were common arcs, I believe most everybody is familiar with. But 104 is not. So again, you can put it here or just times pi over 180, makes no difference. Now, remember, pi is not 3.14, but rather pi is 3.14159, and it continues indefinitely. So please put it to a calculator, how many decimals, whatever they ask you. And so if they don't, you want to carry a lot of decimals, preferably go with an exact answer, 1.815 radians. Now, when you convert from radians to degrees, and again, you have a choice. This is the radian. You can put it here and find the D. Or you say 1 radian is 180 over pi degrees, so multiply each one by 180 over pi. So clearly pi cancels out pi, 180 over 2, 90 minus 90. This is a common arc. We really should know that. Same thing for 5 pi over 6. Okay, so remember, if you want to go this route, t over 180 is minus pi over 2 over pi. So you can go this route or just multiply by 180 over pi. Which one is easier? It's your choice. Now, if you do that, obviously, the pi's cancel each other. 180 cancels out the 6. You get 30, and you get 150 degrees. Again, another common arc. 5 radians isn't a common arc. So 5 times 180 divided by pi. Again, please do not divide by 3.14. It will be wrong. Put it into a calculator with a lot of decimals because pi is 3 point. Let me just write that. It's important for everybody to know that pi is 3.14159, and it continues indefinitely. So 286.48 degrees. Just a rough estimate. Remember, for example, pi is about 3.14. So 3.14 radians is 180 degrees. Okay, just to give you an idea. The latitude of a location L is the angle formed by a ray drawn from the center of the Earth to the equator, this line, and a ray drawn from the center of the Earth to that location, we call it L. So anything you want. So from the center to the equator and to the location. Now, Glasgow, Montana is due north of Albuquerque, New Mexico. Find the distance between Glasgow, which is approximately at 48.15 for 48 degrees 9 minutes north latitude, and Albuquerque, which is approximately at 5.083 degrees or 35 degrees 5 minutes north latitude. Assume the Earth's radius is about 4,000 miles, 3,960 miles. It's about 4,000 miles at the equator, and it changes obviously at different locations, but at equator. So having said that, we need to understand that this is the idea, Glasgow and Albuquerque. Okay, so each one has it, and we want the distance between the two. So if we put it into a circle to make it easier to see in the following manner. So here's the equator. Albuquerque is somewhere here. Glasgow is somewhere here. Albuquerque gives us this latitude, 35.083 degrees. Glasgow, the green one, the bigger one, gives us 48.15. So what we want is this distance. This is the S equals R theta. So we have the R, 3960 miles, and theta is the difference between the two angles. Okay, so we are going to use S equals R theta. We have the R, which is 3960. Now, Theta is the difference between the two. This is theta 1, this is theta 2, their difference, and you keep it as degrees first. Later on, you change it to radians. And so central angle between the two cities would be the difference between the two angles. So 48.15 minus 35.083, you get 13.067 degrees. Now, S equals R theta. We have the R, we have the theta, but it has to be in radians. So this we have to multiply by pi over 180. That gives us the answer in radians. And again, these are all approximations. So however many decimals they ask you, okay? And so S equals R theta, the product of R, 3960. And theta would be almost 903 miles. So a quick recap. We want to find the distance between two cities. Their latitudes are given as 48.15 and 35.083 degrees. So if you want the distance between the two, you find the difference between the two angles. That is the theta that you want to calculate. S, the arc length equals R theta, where R is given as 3960 miles. 3,960 miles, everybody. So I guess that's pretty straightforward. Find the area of a sector of a circle formed by a central angle theta. This is a central angle theta. This is a portion of the area of a circle called the sector, and the formula is half of r squared theta. Let's quickly look at the justification. So the ratio of theta to theta 1 gives us the ratio of area of two regions, A2, A1. And we know the area of a circle is pi r squared. And we know that a complete revolution is 2 pi. So pi is half of 2 pi. And this acts as a theta. Therefore, 1/2 theta r squared, or half of r squared theta. That is the justification for that. So having said that, find the area of a sector of a circle of radius 5 feet formed by an angle of 60 degrees, and they're asking for a couple of decimals. So what you do, you write down area is 1/2 r squared theta. You replace the r with 5 feet and theta with 60 degrees. As you know, it's pi over 3. Class, we all know that. Again, it's a common arc. 60 degrees is pi over 3, has to be in radians. So 25 over 6 times pi, and 13.09, and the units are the units of the radius squared, because area has the units of length squared. Find the area of a sector of a circle of radius 2 feet formed by an angle of 30 degrees. We basically use the same formula. A equals half of r squared theta. R is 2 feet. And angle of 30 degrees, everybody should know it's pi over 6. So we should know 30 degrees is pi over 6. It's a common arc. You don't have to really work it out. You should know that. So this is 2 over 6, 1/3 of pi, 1/3 of pi, or pi over 3, roughly about 1.05. Again, units of area. So whatever the units of radius squared, square feet. Find the linear speed of an object traveling in circular motion. Suppose that an object moves on a circle of radius r at a constant speed. If s is the distance traveled in time t on this circle, then the linear speed, the v of the object, is defined as distance over time, which makes it s over t. So that's pretty straightforward. S over t. Remember, s is the arc length, r theta. So that is the linear speed, distance over time. So we cover this much over time. The angular speed, omega, the Greek lowercase letter of omega, of this object is the angle theta measured in radians swept out, divided by the elapsed time t. That is, as the linear speed is defined as distance over time, angular speed, omega, is defined as angle over time, theta over t. It makes perfect sense. So we want to find the relationship between the two. So it's very straightforward. Omega is angle over time, theta over t. V is S over t, where we know S to be R theta over t. So S over t, we replace the S with R theta. We are separating them into R times theta over t. We know theta over t is omega, therefore V becomes R omega. So that's the relationship between a linear speed V and angular speed omega. And I wrote the formulas here. We can use whatever we need to use. A child is spinning a rock at the end of a 3-foot rope. So that's the case. At the rate of 160 revolutions per minute, RPM, short for revolutions per minute. Find the linear speed of the rock when it is released in mph, miles per hour. Now, first, RPM, revolutions per minute, okay? If you look at the units, you have to multiply the RPM by 2 pi to make it radians, okay? Radians per unit of time, whatever that they give you, okay? If it's revolutions per minute, then it will be radians per minute. If it's revolutions per hour, then would be radians per hour. So you multiply the revolutions by 2 pi to change it to radians, okay? A complete revolution is 2 pi radians. So what is given? R is 3 feet. Omega 160 RPM, revolutions per minute. V, the velocity, the linear velocity is missing in action. So the very first thing is that we have to go from omega in the form of a RPM to radians per minute, which means we have to multiply this guy by 2 pi. So omega is 2 pi times RPM to change to radians per minute, and we get 2 pi times 160, which is 320 pi radians per minute. V is R omega. So R omega. That's why the given helps. 3 times 320 makes it 960 pi, roughly at 3016 feet per minute. As far as, again, a number of decimals, you want to be careful and pay attention to what they want. If they don't ask you, you want to go with many, many, many decimals. Having said that, we are practically done. The only thing is we want to change this unit from feet per minute to miles per hour, reminding everybody 1 mile is 5,280 feet. So I'm going to write the velocity is found, 3,016 feet per minute. And we want to change this to miles per hour. So I'm going to put the miles per hour at the end. This is what we want. So it's very simple. 1 mile is 5,280 feet. And that is the unit conversion. So 1 mile, because you want the mile at top, you put 1 mile at top and you put 5,280 feet at the bottom. This is minutes. We wanted miles per hour. You know 1 hour is 60 minutes. So you want to cancel the minutes. So you put 60 minutes at top, 1 hour at the bottom. So take a look. 1 mile is 5,280. Please understand this ratio or the reciprocal of that is a unit conversion. But since we want to get rid of the, so right here, we want to get rid of that, okay? And then 60 minutes, we want to get rid of that. And now you put it into a calculator, 34.273 miles per hour. So the conversion, I hope everybody is comfortable. Okay. An object is traveling around a circle with a radius of 8 inches. If in 40 seconds a central angle of 1/3 radian is swept out, what are the linear and angular speeds of the object? The very first thing we do, again, the formulas are here, we have to write the given. And that is R equals 8 inches over the time of t equals 40 seconds. The angle theta is 1/3 radians. We are interested in omega and V. We want both of them. So first, this is explaining what's given, what's missing. And so having said that, we go with the definition. Omega is theta over t. So plug in. So theta, so that's why when you write the given, it makes it easier to follow. It's 1/3 and t is 40. So it's 1 over 120 or 0.008 units radians per second. So that is angular velocity. What about the linear velocity? R omega. R omega. R is 8 omega. Let's go with this number because we want to go with the exact, okay, 1 over 20. We can get rid of the 8, 120 becomes 15. So this is exact and roughly 0.067 units, inches per second, because the radius has the units of inches and per second. Again, we have the question and we go over the answer only. So the minute hand of a clock is 6-inch long. So this is the hour, this is the minute, this is the second, this is 6-inch long. How far does its tip move in 15 minutes? Well, so what is given? R is 6 inches. So over the course of 15 minutes, we want to find the theta and therefore S, because how far does it tip? Does its tip move? That means what arc length it covers. So R is 6, the proper units, inches. In part A, 15 minutes, we calculate the theta and then S. Of course, I hope everybody knows 15 minutes is 1/4 of an hour, 1/4 of a revolution. So 15 over 60 times the revolution, or for 1/4 of a revolution is 2 pi radians. And we get pi over 2. So in 15 minutes, it covers pi over 2. radians, pi over 2 radians. And so S equals r theta. That makes it 3 pi units of the radius. 3 pi exact, roughly 9.42 inches. Now, what about 25 minutes? Same methodology. We want to calculate the theta. Instead of 15 over 60 is 25 over 60. Same methodology. Simplify it to 5 over 12 times 2 pi, and you get 5 pi over 6 radians. So again, we are looking at the proper units. S equals r theta. R is the good old 6 inches, and they cancel each other. It's precisely 5 pi, roughly 15.71 inches. So a quick recap. We need the radius. That means the length of the minute hand. And how far does it live over the course of so many minutes? We have to change this to theta. 15 minutes is 1/4 of a revolution. 25 minutes is 25 over 60 times a revolution, or 2 pi radian. So that's how we figure it out. So it's pretty straightforward, everybody. We are going to move on. A 40-inch pendulum swings 20 degrees each second. So remember the pendulum going back and forth, right? How far does its tip move each second? Well, again, first let's write what's given. A 40-inch pendulum, okay, that means the radius is 40, and theta is 20 degrees. And how far does it move? That means S, the arc length. So R is 40, the proper units inches. Theta is 20 degrees, and we are interested in calculating S. And again, first we have to change this to radians by any method. D over 180 equals R over pi, or times pi over 1 over 80. Either way, we get to the answer in radians, which is pi over 9. And we're going to keep it as pi over 9. You want to do the rounding at the end, so keep it as pi over 9. And so S equals R theta. We have the R, we have the theta in radians, plug in. So precisely 40 pi over 9, roughly 13.962. Since they said 2 decimals on purpose, I'm showing you more decimals, because when you want to round it, you have to figure out, you can't stop here. You have to go to the third one to make a decision. And when you make a decision, because it's a number which is 5 or larger, this goes up. Otherwise, it remains unchanged. So it remains unchanged, 13.96 inches. A water sprinkler is to cover a field of 100 square yards. So we want to cover this much. And this has a area of 100 square yards in the shape of a sector of a circle of radius 15 yards. So the radius is 15, and this creates a circular shape. What is the angle needed for this rotation? And they are asking for 2 decimals. So what is given? What is missing? First and foremost, the area is given, 100. yard squared or square yard. The radius is 15. What is missing? The angle theta. So this is the angle that we want to find. So I hope that's straightforward. What is given, what's missing. So area is 1/2 r squared theta. Plug in, find the missing one. So we have everything. We have the area, we have the radius. What is missing? Theta in radians. This gives us theta in radians. And so you go through the process, 15 squared, 225 divided by 2. So you can multiply this one by 2, 200 divided by 225, and you get this number, and it's 8/9 radians. However, normally we want this in degrees. So to go to degrees, do it as you wish. For example, d/180 is r/pi, where r will be replaced by 8/9. Cross product will give us the degrees 180 times 8/9 divided by pi. That's 160 divided by pi, 50.93, almost 51 degrees. So the product of these two is 160, everybody. A windshield wiper's arm and its plate are 30 inches. So from here to here, okay, the entire thing is 30 inches long. If the blade is 24 inches, this is 24, the green part. And the wiper sweeps about the angle of 125 degrees. The angle that it covers is 125 degrees. How much window area can it clean? With 2 decimal places. I want to make sure we understand what's going on here. So this is the entire thing 30 inches. And this is 6 inches. So this is 30. We call it R1. This is 6 inches. So basically what you do, you want to calculate the window area, the blue area. So you calculate the area of a sector for the entire thing with the radius of 30 inches, then they shaded the gray area and subtract it. So what is given? R2 is 6 inches. So arm plus blade, we call it R1 is 30 inches, blade is 24 inches, and theta is 125 degrees. We want the blue area. Please understand that when we use half of r squared with r being 30, it gives you the blue area plus the gray area. So we need to calculate the entire area and then subtract the gray area. So half of R1 squared theta minus half of R2 squared theta. What is R1 here? What is R2? This one. So R1 is 30, R2 is 6 because the blade is 24 inches. So blade is 24 inches. The arm is R2 equals R1 minus 24, which makes it 6 inches. Okay. Because R1 is 30. So again, class, this is so 30 minus 24, 6 inches. We already know that. Okay. All right. So R1, again, we want to make sure that is clear. R1 is 30, R2 is 30 minus 24, which is 6. Theta is 125 degrees, 25 pi over 36. I'm assuming from degrees to radians and vice versa. It's not a big deal. So plug in into this formula, number 30 calculated, and then plug in 6 and calculated the difference, the answer. So half of 30 squared, 25 pi over 36, half of minus half of 6 squared, 25 pi over 36. You can put it into a calculator. Of course, 30 squared is 900, 6 squared is 36. They cancel this one. And so we get, after we put it into a calculator, 1,100, 11,250 pi over 36 minus 450 pi over 36. And it ends up being 300 pi, which is almost 942.48 inch squared. Okay, a quick recap, class. I want to make sure you understand the concept is very simple. The way it's given this entire distance, which gives us R1 is 30 inches. So we put it into this formula and we find the total area. Then this little one, okay, because the blade is 24, this one is 6. The gray area, we put number 6 into this formula, we calculate the area, the difference is the answer. So it's very straightforward as far as the concept is concerned, everybody. An object is traveling around a circle of radius 2 meters. It travels 5 meters in 20 seconds. What are the angular and linear speed? First and foremost, what's given? Well, R is 2. It travels 5 meters. S is 5 meters over the course of t equals 20 seconds. We want to find the V and omega. V, the linear velocity is S over t, and that is 5 meters over 20 seconds. That gives us 1/4, and the units of meters per second. We also know V is R omega, which makes omega V over R. So we divide this one by the radius of 2, gives us 1/8 of a radians per second. Very straightforward, everybody. Again, a quick recap. The radius is given. The arc length is given. The time is given. So V is S over T, and also V is equal to R omega. We can find both of them. A centrifugal force ride, similar to gravitron and amusement ride, spins at 22 revolutions per minute. If the diameter of a ride is 12 meters, what is the linear speed of the passengers in kilometers per hour? So first and foremost, what is given? As you read the question, this is omega, 22 RPM. R is 12 divided by 2. R is 12 divided by 2, 6 meters. V is missing. So this is the RPM, 22. This is divided by 2 to give us, we divide this one by 2 to get the radius, because diameter is 2 times the radius. And we are interested in finding the V. In order to find the V, which is R omega, we need to find the omega in radians. Remember, omega given is in RPM, so you have to multiply it by 2 pi. So 2 pi times RPM gives us radians per unit of time. The unit of time is minutes. So let's multiply this by 2 pi. So 22 by 2 pi. We get 44 pi. Let's keep it as pi for now. Radians per minute. V is R omega, so multiply this one by R, which is number 6, and we get 264 pi meters per minute. Okay, meters per minute. We are done, except they want it in a different unit, kilometers per hour. So we're going to change it according to what they want. Okay, everybody, but understand, for all practical purposes, we are done. So we have 264 pi meters per minute, and we want it in kilometers per hour. All right, so what do we know? We know 1 kilometer is 1,000 meters. Okay, because the meters is up here, we put 1 kilometer up, 1,000 meters down. Minute, we know 1 hour is 60 minutes. We want to get rid of the minutes, we put the minutes up, hours down. So first and foremost, right here, we're going to get rid of the meters here. And then right here, we are going to get rid of the minutes. Now you put this into a calculator, 264 pi times 60 divided by 1,000. We end up with 49.763, and the units of interest, kilometers per hour. So my suggestion is, when you finish the job here, then try to change this to the units of interest. I would put the number and the units that I found, and then I put the units at the end that I want, and I try to make the changes necessary to give me the answer. A DVD drive has a maximum speed of 7,200 RPM, revolutions per minute. The DVD has a diameter of 12 centimeters. What is the linear speed in kilometers per hour of a 0.5 centimeters from the disk center if it is spinning at the rate of 5,400 RPM? First, I want you to know, whatever the diameter or the radius is, it doesn't matter. We are at a different point, so that really doesn't come to effect. Okay, so what is given? Of a 0.5 centimeters from the disk center, that means R is 5 centimeters. Spinning at the rate of 5,400 RPM, that is omega. And we are looking for the linear speed V. So given R is 5 centimeters, omega is 5,400 RPM, and linear velocity is missing. And so having said that, V equals R omega, but first we have to put the omega from revolutions per minute to radians. We have to multiply the omega by 2 pi. So 2 pi times RPM, that means 2 pi times 5,400. That gives us 10,800 pi radians per minute. Again, this is exact. We keep it exact until the end. V is R omega. So we multiply R, which is 5, by this number. So we get 54,000 pi centimeters per minute. So we are done finding the linear speed. However, we want it in kilometers per hour. So again, now the next one is elementary algebra. We are going to write the given that we just found. And how do we want it? In kilometers per hour. So let's make the changes. So we have centimeters. We want to change it to kilometers. Remember, 1 meter is 100 centimeters. 1 kilometer is 1,000 meters. We want hour. 1 hour is 60 minutes. So I put 1 meter over 100 centimeters, 1 kilometers over 1,000 meters, and 60 minutes over 1 hour. So notice what happens. This cancels out this one. This cancels out this one. This cancels out this one, and we get the kilometers per hour. Now, you simply multiply this number by 1 by 1 by 60 and divide the result by pi, keep it as pi, divide by 100,000. And when you do the job, you get 101.8 kilometers per hour. By the way, roughly 1 mile is 1.61 kilometers, just to give you an idea. So if you divide this by 1.61, roughly gives you miles per hour. Now, the radius of each wheel of a car is 15 inches. If the wheels are turning at a rate of 3 RPS, revolutions per second, how fast is the car moving? And they want it in inches per second and miles per hour. So first and foremost, what is given? R is 15. Omega is 3 RPS. Linear velocity V is missing in action. So first, change the omega from revolutions to radians. So you have to multiply by 2 pi. And you get 6 pi radians per second, the same unit of time that was given. And now V equals R omega. We have R equals 15, omega equals 6 pi. We get 90 pi inches per second. And you, if you want to finish this job, roughly you go with, I don't know, however many decimals they ask you, 282.7 inches per second. Now, I'm going to put that, and I'm going to put what they ask miles per hour here. So we're going to make the changes. So remember, 1 mile is 5,280 feet. 1 foot is 12 inches. 1 hour is 60 minutes times 60 seconds, or 3,600 seconds. So I hope no one has any problem with the unit conversion. So 1 foot, 12 inches, 1 mile, 5,280 feet, 3,600 seconds over 1 hour. Now, where do you put them? 1 hour at top or 3,600 seconds at top? You have to figure out what you want to cancel. Notice the second cancels the second here. This inch cancels the inch here. And this one cancels out this one. So the units work out. You do the math, and you end up with 16.1 roughly miles per hour. The mean distance of Earth from the sun is 9.29 times 10 to the power of 7 miles. Assuming that the orbit of Earth around the sun is circular, which is not, but it's very close, and that one revolution takes 365 days, again, it's 365 days and 1/4 of a day roughly. Find the linear speed of the Earth in miles per hour. These are all approximations. So what is given? What is missing? First and foremost, the radius is given, R is given. Omega is 1 revolution per 365 days. We have revolution per year. We want to go with revolution per day. And then we want to go with revolution per hour. So those are the changes we want to make. And omega is stayed over t, which is 1 revolution over 1 year, or 365 days. So omega is stayed over t, 1 revolution over 1 year, or 365 days. 1 revolution is 2 pi radians. So that's our omega. 2 pi radians per day. 2 pi over 365 radians per day. So we have so many radians, we have so many days. And now in 1 day, there are 24 hours. So 2 pi over 365 These are in radians, these are in days. 1 day is 24 hours. Okay, notice this cancels this one. So we get radians per hour. So we get 2 pi times 1, okay, 24 times 365. And as you know, these 2 cancels at the 24. That's how we get the 12. Again, we are keeping it as precise for now as much as possible. So that is pi over 12 times 365 radians per hour. And V equals R omega, everybody. So V equals R, which is this number, 9.29 times 10 to the power of 7, times omega, which is this number. V equals R omega, plug in. So R is 9.29 times 10 to the power of 7 miles. And omega is pi over 12 times 365 radians per hour. You put that into a calculator, and it gives you 66,633.324 miles per hour. You can estimate very close to 67,000 miles per hour. That is fascinating. So, and that's really the idea behind this concept, understanding that everything is moving and everything is moving very fast. So about 67,000, roughly 67,000 miles per hour. Two pulleys, one with the radius of 2 and the other with the radius of 8 inches, are connected by a belt. Okay. If the 2-inch pulley is caused to rotate at 3 revolutions per minute, 3 revolutions per minute, determine the revolutions per minute of the bigger one, the 8-inch pulley. What about radians per minute? The linear speeds of the pulleys are the same, both equal the speed of the belt. So that makes perfect sense. Remember, they have equal linear speeds. And so we're going to write R1 is 2, R2 is 8, omega 1 is 3 RPM, omega 2 is missing. So if the two speeds are the same, then this one is R1 omega 1, this one is R2 omega 2. They both have the same speed. So plug in. R1 is 2, omega 1 is 3, R2 is 8, omega 2 missing in action. So omega 2 is 6 over 8, or 3/4 of a revolution per minute. Now, what about radians? Remember, this is RPM. You have to multiply it by 2 pi to get radians per minute. So 3/4 of a revolution per minute times 2 pi is 1.5 pi radians per minute. Example number 19, Earth rotates on an axis through its poles. The distance from the axis to a location on Earth 40 degrees north latitude is about this much, 3,033.5 miles. Therefore, a location on Earth at 40 degrees north latitude is spinning on a circle of radius 3,033.5. So remember, the radius along the equator is about 4,000 miles, 3,960. But as we, go away from that, it becomes smaller. So this is 40 degrees. That's why it's smaller. And it's smaller almost by 1,000 miles, almost. Compute the linear speed in miles per hour on the surface of the Earth at 40 degrees north latitude. So what is given? R, and we want the 40 degrees is just a piece of information, doesn't enter the calculation. Omega is 1 revolution per day, and we are interested in calculating the linear velocity v. And remember, we want to go with the radians. 1 revolution per day means 2 pi radians per day. So that's the first thing we want to go with, radians, everybody. And of course, day has 24 hours. So we're going to divide this by 24, divide this, and it becomes pi over 12 radians per hour. V equals R omega. R is for 40 degrees north latitude, this much, 3033.5, and omega is pi over 12 radians per hour, and we end up with 794.17 miles per hour, so almost 800 miles per hour. Almost 800 miles per hour. And of course, it's more at the equator. Close to that's about 1,000 miles per hour. In this case, close to 800 miles per hour. To approximate the speed of the current of a river, a circular paddle wheel with radius 4 feet is lowered into the water if the current causes the wheel to rotate at a speed of 10 revolutions per minute. What is the speed of the current in miles per hour? So let's figure out what's given. R is 4 feet. Omega is 10 RPM. V is missing. And the very first thing we need to know that omega has to be in radians, so this has to be multiplied by 2 pi. So we have 2 pi times RPM, 2 pi times 10 gives us 20 pi radians per minute. V equals R omega, where R is 4 feet and omega is 20 pi feet per minute. So we have 80 pi feet per minute. So we want to change this to miles per hour. This is 80 pi over a minute. And remember, 1 mile is 5,280 feet and 1 hour is 60 minutes. So 80 pi feet over a minute, 1 mile over 5,280 feet, 60 minutes over 1 hour. And we see that the minute cancels out the minute. Feet cancel out. So 80 times pi times 60 is in the numerator, and the denominator is only 5,280. And putting it into a calculator ends up giving us the answer, which is 2.86 miles per hour. So you can calculate the speed of the current in a river using this methodology. A Ferris wheel whose radius is 30 feet takes 70 seconds for 1 revolution. What is the angular speed in radians per second? What is the linear speed of this Ferris wheel. So first and foremost, what is given? R is 30 feet. And this is omega 1 revolution per 70 seconds. So that's the given. The first thing we need to do is to change the units for omega from revolutions to radians. So we have to multiply this by 2 pi. So 1 revolution per 70 seconds equals 2 pi over 70 seconds, or pi over 35 radians per second. V equals R omega. R is 30. Omega is pi over 35. We get 6 pi over 7 precisely, roughly 2.69, 2.7 roughly feet per second. That is the linear speed, everybody.